To find if a set of numbers is a solution, we have to substitute it into all three equations. If it satisfies all three equations, then it is a solution. So we're going to begin with our first equation, substituting 0.5 for x, 2 for y, and negative 1 for z. We're going to see if it satisfies the first equation. So we'll have 1.0 plus 2 plus 1. We'll test if that's equal to 4. So 1 plus 2 plus 1 is indeed equal to 4. So it does satisfy the first equation. So we have to go on to the second equation. Substitute 0.5 for x, 2 for y, and a negative 1 for z, and see if that's equal to negative 2. So in this case, we'll have 2.0 minus 6 plus 2, and is that equal to negative 2? So we have negative 6, 2 minus negative 6 is negative 4, plus 2 will be negative 2 is equal to negative 2. So it does satisfy the second equation as well. Now we're going to go down and check the third equation. I'm just going to do it down here. So we have 8, 0.5, minus 2, substitute the 2, minus 3, substitute the negative 1, and we're going to check and see if that's equal to 3. So 8 times 0.5 will give us 4. Negative 2 times 2 is minus 4, and negative 3 times negative 1 is a plus 3. So our 4's will cancel out, and that will leave us with 3 is equal to 3. And because all three equations are satisfied, we can say that the 0.5, 2, and negative 1 is the solution. Now we're going to go through our subsequent sets here just to prove that they are not a solution. So we're going to substitute in the first equation our negative 0.5 plus 2, negative 1, and test and see if that's equal to 4. We have negative 1.0 plus 2 plus 1, and we're testing if that's equal to 4. The 1's are going to cancel, and we're going to have 2, which is not equal to 4. So we know that that is not a solution because the first equation is not satisfied. Now if we go into our third and fourth sets, we're going to again begin by substituting the values in that first equation. Minus 2, minus 1, see if that's equal to 4. So we have 1 minus 2 plus 1. The 1's will cancel out. It will leave us with a negative 2, which is not equal to 4. So we know that would not have been a solution because it does not satisfy the first equation. And then in our last set, we're going to substitute that into our first equation again. So we get plus negative 2, get minus negative 1, and we're going to test and see if that's equal to 4. So we have negative 1 minus 2 plus 1. Is that equal to 4? The 1's will cancel out. Negative 2 is not equal to 4, so we can conclude that that is not a solution either because it does not satisfy the first equation.